welcome to lecture number 42. So, already we have solved we got this equation for the Lagrange points under the condition that y equal to 0, z equal to 0, and this we have got in the normalized form. Now, we have to solve it. So, in the while solving for Lagrange points, what we realize that if we have mass m 1 here, mass m 2 here. So, I can have, and barycenter obviously it is a lying in this place. So, m can lie either here in this place, or either it can lie somewhere intermediate to these two masses, or either it can lie here in this place, and accordingly these masses are named as these positions are named as, this is named as L 2, this is named as L 1, and this is named as L 3. So, these are the three Lagrange points L 1, L 2, L 3, and as you know that at the barycenter we fix the reference frame, and in this direction we have taken x s to be positive and downward we have taken y s to be positive. So, here in this direction your x will be greater than 0, and from this place onwards x will be less than 0, where x is the normalized value as we have written x divided by r 1 2. R 1 2 is the distance between masses m 1 and m 2. So, here this distance is r 1 2. So, we consider the first case here, case 1. X is greater than 0 and lies to the left of mass m 1, lies to the left of mass m 1, which is shown here. This is the mass m 1 here in this place, and the Lagrange point, the smaller mass m is either lying here, either lying here, or either lying here. So, we are considering the first case, which is corresponding to L 3. So, x is greater than 0 and lies to the left of mass m 1. Okay. So, in that case immediately what we can see that x minus mu star, and what is mu star? As we know from our earlier discussion, this mu star is nothing but this distance, and this distance is 1 minus mu star. Okay. So, therefore, you can see that if x is up to this point from here to here, if x is from distance from this place to this place, this is capital X. So, capital X minus x s will be this capital X minus mu star, this will be a positive quantity. So, this is a positive quantity, and also x plus 1 minus mu star, this is also going to be a positive quantity, and therefore, equation 1 gets reduced to x equal to 1 minus mu star, x minus mu star divided by whole cube, because it is a positive quantity. Therefore, mode we can write like this, the mod function, this is basically the sign for the modulus of any quantity, mu star x plus 1 minus mu star divided by x plus 1 minus mu star whole cube, and then this then gets reduced to x equal to 1 minus mu star divided by x minus mu star whole square plus whole square, and this we name as equation 2, and this equation gives you the solution to this equation, you will get L 3, and this gives you a quintic. This is basically fifth degree polynomial, fifth degree polynomial. Okay, so we do not have much trouble in solving for L 3. Then we take L 2, which is also easier to work with. Case 2. Point L 2, okay, which is, so here in this case x is less than 0 and lies right of the, here it lies to the left of the mass m 1, here in this case lies to the right of mass m 2. So, again drawing the figure here, these are the masses m 1 and m 2. Barycenter is located somewhere here, x x is positive in this direction and y s is positive in this direction as per our assumption. And the point L 2, now we are assuming that it is a lying somewhere here, this is mass m L 2. So, in this direction, this is your x distance, the location of the third mass. Of course, the distance from this place to this place, this is 1 minus mu star. Now, because we are solving for the values, so what we will do, instead of writing here, because this is negative direction, so I will insert a negative sign here in this place. So, this indicates that x we are taking as positive, 1 minus mu we are taking as positive, and this minus sign implies that we are going opposite to the x direction. So, this way we will be able to get the once we get the equation and we can solve it. So, that will give us the proper value of the x. So, for that case, then equation 1 can be rewritten as so for this case equation 1 can be rewritten as minus x, we replace this x by minus x in this expression, minus x equal to 1 minus mu star, this remains as it is, x gets replaced by minus x minus mu star divided by minus x minus mu star whole cube plus mu star times minus x, again this part, this x we are replacing by minus x, and then 1 minus plus 1 minus mu star. So, this is plus 1 minus mu star. So, what we are looking for, this is the basically the distance from this point to this point. this is total distance from here to here, this is minus x, okay. And to this part you can also look like this. This is minus x minus 1 minus mu star. You can say, so that becomes plus. So, from minus x you are subtracting the quantity, a negative quantity minus 1 mu x. So, that gives a positive value. So, ultimately this gives you a vector along this direction. And the same way here in the denominator we have minus x plus 1 minus mu star whole cube. This minus sign we eliminate from both the sides. This gets reduced to 1 minus mu star, and this gets x plus mu star, and here also this will get reduced to using the mods property. So, here if we look here in this place, once the minus sign is removed, this is indicating a positive quantity. Similarly, this is 1 minus mu star, this is also a positive quantity, because the magnitude wise this x is greater than 1 minus mu star. So, we can break this bracket, the mod sign, and we can write it like this: 1 minus mu star divided by x plus mu star whole square and plus mu star divided by x minus 1 minus mu star whole square. So, this is your equation number 3. So, ultimately what we have concluded, that for Lagrange point L2, x equal to 1 minus mu star divided by x plus mu star whole square this is expression number 3. So, L1 and L2, L3 and L2 we have worked out. Okay. This is your L2 point located here in this place. Now, we are left with the L1 point, which is intermediate to M1 and M2. Now, we need to sort out this problem. So, as usual, M1 and M2, M1 and M2, these are the masses. Barycenter is located here in this place. In this direction, we have taken as x x, this is y s, and barycenter is located here. This distance we have written as mu star, and this distance we have written as 1 minus mu star from here to here. And the point L1, it may be lying somewhere, let us say in this place. So, this distance will indicate by x with minus sign. Why? Because it is a line toward the negative x direction. This is our synodic frame. Okay. So, it is lying along the negative x direction of the synodic frame. This case is bit complicated and we have to work it carefully, okay, because it lies intermediate to the point masses m 1 and m 2. So, here in this case the primary problem, see we have what we are concerned with, that this and this should be taken care of. We are not worried about this, because it is a scalar and it remains as it is. So, we have to worry just about these quantities. So, the equation 1 can be then rewritten as in this case as x has to be replaced by minus x, but other things we have to be very careful while writing. So, here there is no change, but the other part we have to be careful. Okay. So, now we have this plus sign. So, plus sign I have taken, this part we have to be careful in this particular one. Minus x goes as it is, minus x is this distance. So, whatever things were there, x plus x b 1 was, it was written like this. Now, here in this case what we see, that x b 1 is the distance from here to here, while x is the distance from this place to this place. This is, let us say, the small x in terms of writing in terms of a small x. Okay. So, what this was indicating, this is part of the vector r 2 square equal to x plus x b, this is b 2, this is x b 2. So, this x b 2 square plus y square plus z square, and when y and z they are 0. So, r 2 square then becomes x plus x b 2 square, and we have to consider it in this format. So, this x we are replacing with minus x in the normalized form, okay. And this x b 2 here in this case. So, x b 2 it has to be replaced by, we write it this way. See, this minus from this point to this point, this is your x, and that too with minus sign as indicated here. So, this is minus x. So, that we are choosing x as positive by putting with a minus sign here. Okay. So, this part has been replaced, and thereafter we have the quantity x b 2. So, x b 2 we write it by minus, see this quantity r 2 square, this is now here x minus x b 2, because it was in negative direction, it is a result of this. If you remember, in the beginning once we have started working for the restricted 3 body problem. So, we wrote at this stage in this way. So, this x we are replacing with minus x, which is appearing here in this point, okay. And thereafter this is minus and then minus x b 2. Okay. Here once we are writing here in this way. So, we are ensuring that this x b 2 is appearing as a positive quantity once we have written that way. So, we write it here in this way. And then this divided by minus x minus mu star whole cube. And then let us rearrange it. So, we have if we take this minus sign. So, this we can make here minus, we can replace this with a minus sign mu star, and here we have to be careful. Now, in this case what we see that the quantity 1 minus mu star, this is the magnitude minus x, this quantity is greater than 0 for L 1, where x once we are writing. So, we are considering the magnitude, and also this is a magnitude, okay. Means they are positive quantity here. So, we have to write in a way so that our problem gets solved. Okay. Here we are interested in breaking up this and this. We have to cancel out the numerator and denominator. So, the upper one we can write as 1 minus mu star minus x. This is a positive quantity according to this, and the lower one similarly we can write here 1 minus mu star minus x whole cube. This is a positive quantity magnitude wise. So, therefore, we can remove the mod sign and write it in this way. Now, this can be rewritten as 1 minus mu star x plus mu star, x plus mu star we can cancel out from the numerator and denominator, and simply we get here x plus mu star whole square, because this quantity is positive. Therefore, we can replace it by this square sign in the normal bracket, and then this part we have to write. So, this is mu star divided by 1 minus mu star minus x square, because this quantity is positive and this quantity. Here also we can put it like this at this stage itself. So, because this is positive, and therefore, in the numerator denominator we can break it out. So, the quantity we are following this. Okay. So, this quantity mod of 1 minus mu star minus x, this quantity will be equal to 1 minus mu star minus x, and this is what we have followed here in this place. Therefore, to finally conclude, x we get as 1 minus mu star divided by x plus mu star whole square minus x square, and this is our equation number, this is 3. this Lagrange point L 2, Lagrange point L 3 we have got here. So, this is our Lagrange point L 1 and this we name as equation number 4. So, these are the 3 equations we are having for solving the Lagrange points. So, finally, I list them in one place for easy reference. So, first we list L 3 equal to x equal to 1 minus mu star divided by x plus mu star whole square plus this is related to Lagrange point L 3. Then I list for L 2 where the x is written as the numerator remains everywhere the same, only thing the denominator will change. X minus this is x minus whole square and the third one So, this quantity one thing you should note it here the quantity in this bracket this can also be written as x minus 1 minus mu star whole square, because this is always either you write this first or this first, it does not matter because there is a square here. So, squared means it is either whatever way it is written it will become positive. So, it does not matter in that case and therefore, we will rewrite in that format. So, this becomes x minus 1 minus mu star whole square, this is equation C. So, let us verify this. Here 1 minus mu square, there is a minus sign here. Okay. So, there is a minus sign here, this is okay. And then we have this point x minus mu star, there is a plus sign, x minus mu star, there is a plus sign, this is also okay. And finally, this remains as it was there. So, these are the 3 equations and if we solve them and they are quintics. So, these are quintics and if we solve them we get the solution for x, and I did it on MATLAB and so you can try using your own calculator if it is a possible programmable calculator you can do, but on MATLAB you can find the roots of these equations once you have rewritten them, only then it is possible. So, say in the case of this is case 1, case 2 and this is here this is L 1, the last one we have considered as L 1 and this is case 3. So, for case 1, if we rearrange this equation, so finally, this you can do yourself, I am not going to write it here. So, this can be rewritten as x to the power 5 plus 2 minus 4 mu minus 2 plus 4 mu plus mu square minus 2 mu cube plus mu to the power 4. These are all stars. I have not written here stars, but it is indicating star. Times 6, and the last term will be plus therefore, this equation can be written as x to the power 5, and this this coefficient I will name as a to the power 4. A to the power 3 . So, this is a quintic, and solve it to get the solution of x. So, this is for case 1, which is referring to L 3. The same way equation can be developed for others. Okay, so, the rest of the things we will take in next lecture. We stop here. Thank you very much.